Good afternoon, everyone, or good morning, based on where you are in the world. Am I audible clearly? Some of the panelists can answer.
Yes, we can hear you.
Okay, very good. So it's almost exactly 4 p.m. So thank you all for joining us from all over the world. It's a pleasure to have you. I assume most of you are joining from your homes, given that it's a COVID world. Okay. Excellent. I'm glad that everything is clear and you could join us. Let me begin. By way of introduction, I'm CTO of Tejas Networks, Kumar Shivarajan. Okay, so what I'll talk to you today is how to build agile networks to manage the broadband surge. I'm sure all of you are experiencing a broadband surge right now. I'm sure I am. Just to give you my own story, I had 250 gig a month. I never exceeded that, except in April, by the 25th, I had run out. I'm now upgrading to a terabyte per month. So I'm sure the same is true of many people around the world who are working from home, longer hours. I'm sure the same is true of many of you as well. So what I'll do today is run you through a few things. Just checking, yeah. So the agenda is I'll discuss what's happening to telecom in this post-COVID world. What's changing? What are the new network requirements? What are the technologies we need as service providers and equipment providers to adapt? And what is our recommended approach to change your networks, to evolve it, to transform it, to scale it in this new world? So just one moment, please. Okay, I think I have my video on. I will just pause it. Someone can pause my video for me. Okay, so what's happening in 2020? So businesses, we are all used to working from home. I think pretty much everyone on this webinar, at least from Tejas, is working from home. We are using video conferencing, all other modes of interaction. I think there is a sudden need to have collaboration tools from Microsoft and so on for greater productivity in the office. We had our sales conference at Tejas, which is a virtual event for the first time in 20 years. All data is moving to the cloud faster. Healthcare, I think these haven't caught up. They're very busy treating COVID right now. But I think once they get around to the regular problems, telemedicine may make a comeback in some shape and form, or at least start getting increasingly adopted. Hospitals already need, I think, high-speed connections to do this. There's also, all of us are, I think in India, we have an app called Arogya Setu. I'm sure all countries have similar apps where we are monitoring how close we are to a COVID patient and so on. And so those things will continue, I think, almost forever, where public safety will require analytics of places where COVID positive people moving or potential infection and so on. We run a manufacturing output as well, and to make the products, the telecom products that we sell all over the world. And we are having to start thinking about how to automate our factory. Industrial IoT and AI and so on is something we read about. We thought we would eventually get around to adopting it, but now I think the time has come. We will have to adopt it far sooner than we thought we would. Leisure, I'm sure, now everyone's at home. Children are at home, whether you have school-going children or college-going children. They are attending classes from home. and the rest of the time they're streaming video from home as well. So e-commerce, commerce through social media, regular sports to whatever degree we had them is now replaced by esports, or some kind of gaming. So this is the new normal, and I think this normal is going to continue for a long time. We'll get used to it, and then maybe we never go back fully to what the world was like in March or February. What is this doing to the network traffic? So first, there is 400% growth in video conferencing traffic, and that's not very surprising given that pretty much everything that used to happen face-to-face is happening through video conferencing. There is a significant increase in upload traffic because we are now, I'm uploading my video from home here. What it means though, most of you are telecom service providers, so you design your network for the overall capacity, maybe wholesale providers. So 50%, there's 50% growth in total traffic, but if you're dimensioning your network for the peak capacity, there's about a 35% growth in peak traffic. So this already means that your network capacity has to increase by 50%. You probably had some slack, maybe you're running your networks at 50, 60%, and now it's chock full. So it's almost immediate need to upgrade, and this may just continue. So let's look at the end-to-end telecom network. So all of us, want to use something on the right, an application. Zoom is what we are using today, or YouTube, or watch movies on Netflix. Connecting, those are all on the internet, and many of you are service providers in this audience. So you would probably be having a backbone network, an OTN, WDM network that connects your users to the internet. Below that, many service providers have an aggregation network, which is largely packet-based, either carrier Ethernet or MPLS TP or IP MPLS, some kind of packet-based aggregation network. Below which sits the broadband network. So broadband access through fiber, FTTH or GPON is what most of us have. In certain remote parts where there is no fiber, there is fixed wireless access. Businesses have Ethernet or fixed wireless access, mostly some form of Ethernet for small businesses. Larger businesses have assured QoS, assured SLA services through MPLS. And of course, there is, for mobile services, you have cellular access. So this is how the end-to-end telecom network looks. Now, if you look at the packet transport technologies, which are sort of in the aggregation portion of the network, Ethernet or Q-in-Q has been widely popular. I think there are many countries, especially early adopters like the US, where there's an extensive installed base of Q-in-Q based carrier Ethernet. So this allows the carriers to build another layer of Ethernet, but there is no reservation of resources. Sub 50 millisecond protection was devised using ERPS. It's called G.8032. So you may be using one of those two terms. A lot of fault and performance monitoring has been added, but there are no connection-oriented services. So it's just connectionless services. And if you have to interoperate with the core, where there's IP MPLS, you just have to hand off Ethernet with VLANs. A newer technology is MPLS TP. That's something many service providers worldwide are deployed, especially where QoS is important. So these are traffic engineered networks. Customer services are carried on pseudo wires or LSPs. There is sub 50 millisecond protection switching and multi-segment protection, but sub 50 millisecond protection switching here is switching of pseudo wires. It's a transport network, so the provisioning happens through the NMS. There is support for circuit emulation, so service providers can move their older circuits to this packet-based network without having to keep their old circuit networks going. Synchronization is also important, and this is making a comeback, especially with 5G. I think with 4G, synchronization got out of the transport network because synchronization was required for timing till then, but then 4G started to use GPS, but I think 5G will cause synchronization to come back. And this is very good O&M features on par or probably better than the Q-in-Q style of networking. So these are the technologies we have. So how do we address this post-COVID requirements? So what are the requirements? So first, I think there is a surge to add broadband connections. There were many users, especially younger users, who used to do all their work from the office, who lived with a mobile phone connection, and now suddenly they can't go to office. A majority of them, in India, we have a large software industry which employs literally millions of people, and a big chunk of that working population is very young, out of college, single. And they were used to just working in the office, have breakfast, lunch, dinner in the office, work there, everything gets taken care of, go home, just have a mobile connection. Now suddenly this entire population is asked to work from home, or 90% is working from home. And they all need broadband connections to keep up with their conference calls and so on. So I think there is a huge surge in broadband connection requirements around the world. I have, people had connections, small home offices. I have an FTTH connection. But, my biggest fear during this webinar is that something will go wrong with that connection and I'll have to switch to some other form of connectivity. And so if I could get an SLA to have, let's say, protection on my home broadband connection, I would gladly go for it. Just to let you know, I have a backup wireless connection going. So in case something happens to my broadband connection, I'll switch over to my wireless connection. So there is a need, and everyone has the same kind of need. Then there is the need to scale the network. I think bandwidth needs to be scaled all the way from access to edge to core. I've already shown you that in 1 month, traffic has grown by 50%. And sometimes this scaling may have to be flexible because you may not be able to simply increase capacity across the board immediately. So you will see peaks and troughs, and you need to be able to flexibly add bandwidth. I think so. The scaling cannot just be a one-time. So you need ability to resize bandwidth. So for example, to scale, you cannot simply be taking down the links or something. So you should be able to add bandwidth seamlessly to the existing links. So that's what is needed post-COVID. So let me give you some examples. So how do you add new broadband users? You probably have a network which has existing business customers, existing residential customers, and then you suddenly get a new customer. It's a hospital which kind of thought they didn't really need a broadband connection. They are managing with some low quality broadband or maybe just a dongle. Now suddenly they request for a high-speed broadband connection. It will take you time to get fiber. So a good option would be to do a wireless connection, a point to multi-point connection. This requires licensed spectrum, but I've talked to many service providers. You might actually find that you did license some WiMAX spectrum in 2010 and forgot about it. I find many customers in that situation. They thought, oh, WiMAX didn't take off, but you could use that spectrum for LTE today. You could rapidly roll out a point to multi-point LTE broadband connection. I'm not talking a mobile connection, just a fixed wireless connection, which will enable you to quickly get new broadband customers on board by putting an outdoor CP out there outside their home. Remember, the mobile connection is not good enough because in many places, a mobile connection gives you maybe 6 GB of data a month. That is typical in the US. In India, people used to be more generous. They give you a gigabyte a day, but I think those things will go down or they'll start charging more. So people are looking for unlimited broadband, something relatively unlimited. So maybe 50, 100 GB a month. And those kinds of things can be done if you have a fixed wireless connection with an outdoor CPE. not a mobile phone, because that's a very expensive, it uses too much of the spectrum. You can't get enough capacity out of the same amount of spectrum if you're supporting mobility. So I think this is a good way to get new broadband customers on board with the kind of high-speed capacities they need in order to work from home. That's really the requirement today. And if you can get fiber, if you can get your labor force out on the streets, lockdowns are lifted, you will be able to then maybe start laying fiber, start shifting at least the heavier bandwidth users to fiber, but still you can keep a lot of connections on wireless, simply because it's very expensive or time consuming to lay fiber to them. So I think this is a very good way, if you have access to spectrum, to get new broadband users on board and later on connect to them with fiber. Businesses, there are small businesses which will and can be served by GPON. So small home offices will start to get served by GPON. Small and medium businesses can get some form of carrier Ethernet, and large businesses can get MPLS TP. Now, I think every business will pay much more attention to the capacities they are getting. So you will start to have to add capacities because, well, people are not in the office, people are accessing the office. So you need a lot more capacity to the office as well. So anytime you remote office workers from the office, you need bandwidth at their homes. You also need a lot more bandwidth at the office, because every resource is sort of sitting there, computing resources and so on. So I think they're going to be need, the businesses will also start seeking increased bandwidth to their office. In fact, I sort of take Tejas itself as an example. We immediately increased the bandwidth into the office from the internet, simply because now everything was coming from the internet as opposed to the LAN. Now, if home offices are, if people are working from their homes, so you have small and home offices, GPON needs to have protection. This is something, if you're an access provider, you never thought of doing, because you thought GPON is like a home broadband network. Protection is really a business concept. But I think now home broadband is the office broadband. So you should consider adding protection for GPON so that you get resiliency at the homes. Of course, you can't do this immediately because your own workforce is under lockdown, but I think sooner you can get a protected form of GPON where you at least protect up to the splitter. I think it's very expensive and probably not economical to protect all the way into the home, but the outside plant could get protected so that people have resilience against fiber cuts and so on. You need to take the protection deeper into the network as well. We need to protect also in the backbone of the network. So here, as service providers, I'm assuming a lot of you are wholesale providers or ISPs. So the typical transmission network is used to give you protection to one endpoint. So rings were a common notion, or even when rings got replaced by mesh, the starting and ending point of the protection was the same. But today, all traffic is internet access. So you don't need to protect between the same 2 points. So let's say these are all broadband access nodes, let's say OLTs for GPON. So all you need to do is reach either Internet Gateway 1 or Internet Gateway 2. You don't really care which Internet Gateway you reach, as long as you reach the Internet. So your protection scheme has to change to just get you to the closest Internet Gateway. And that's what you can do with what is called Open ERPS. It is a standard scheme. It's an extension of the well-known ERPS or G.8032 scheme. So normally you're going to Internet Gateway 1, all your traffic is going to Internet Gateway 1, and nothing is going to Internet Gateway 2. This is sensible because sending the traffic to 2 Internet gateways, will be confusing for the network. But if the fiber gets cut to Internet Gateway 1, then all traffic automatically goes to Internet Gateway 2. And this is the property of OpenERPS. It doesn't try to go back to Internet Gateway 1 because that's pointless. All you need to go do is get to the Internet. And this happens in 50 milliseconds. It is independent of any IP network you have in the core. So this is just a property of the aggregation network. OpenERPS requires some communication between the Internet Gateways 1 and 2, between the ERPS network, but that happens through the IP cloud. There is no requirement for the IP cloud to participate in this protection switching process. There are no interop issues. So something like this you have to consider, and I'm glad to say that one of the recent networks we built in India, which was a GPON network across 4,200 railway stations, for our customer to provide access to all the, the population around the railway station in those small towns. We built this, between June and September of 2019. And I think it is very fortunate because now that entire population across 4,200 towns is connected post-COVID. And I think it was very fortunate that our customer thought of building this very quickly. And the protection there is exactly this way, because it's built along the railroad and you just reach the closest internet gateway on the east or west. There are about 400 internet gateways. You just reach the closest one. And this network's up and operational and keeping much of India connected in this COVID times. You also need QoS, right? So for example, I don't get this from my service provider, but I would definitely pay to get 10 megabits per second guaranteed for this webinar so that the webinar goes well. Typically, you can't get that on a GPON connection, so home broadband traffic is supported on a best effort basis. So I just pray that there aren't enough other users to choke this webinar. But if you're a business traffic customer, you can get, and you should be able to get some kind of SLA where you are at least guaranteed your packet rate. Maybe you're not guaranteed latency or jitter, but at least bandwidth should be guaranteed. You may have to live with occasional latency or jitter issues. But for mission critical traffic, latency should be guaranteed at a very low level, 10 milliseconds, 20 milliseconds. Jitter should be guaranteed as well, and there should be no packet loss. So what this means is that your network should not be either statistically provisioned or over provisioned. So it's not a good idea anymore to say, I'll load my network 50% and hope that no one exceeds, because people are going to exceed because there's so much traffic growth. So for example, if you're running your network with a 60% load, post-COVID, it's running at 100% or more because the peak traffic has grown, right? So now your customers can't run their mission critical applications or even something as simple as an uninterrupted video conference unless they get guaranteed QoS. So I think your network should be capable of giving hard guarantees, saying there is absolutely, your bandwidth is guaranteed, come whatever may, and your latency and jitter is also guaranteed. So that's the kind of network QoS that customers are looking for. You also need to upgrade your network. So if you had a GPON network, you're looking to upgrade to XGS-PON. I think post-COVID, I think we will see a wider adoption of XGS-PON. It's a technology that's been waiting in the wings simply because people thought GPON was enough. But I think now you need to serve many more customers from the same infrastructure, maybe add new customers. And so XGS-PON, I expect, will take off very quickly. We had many business rings, and pretty much all of our business Ethernet and mobile backhaul was connected on 10 gig rings. We will start seeing that move to 100 gig in 2020. So that I expect will happen because businesses simply need much more bandwidth. Fixed wireless access from 4G will move to 5G. As a result, the aggregation network, which used to be multiples of 10 gig, I think will rapidly move to multiples of 100 gig. The core network will move from WDM at 100 gig to WDM at 600 gig. So I think network capacities are going to get upgraded very, very quickly. For upgrading capacity in the core, most of you who are service providers have a WDM network, which may be running 10 gig waves or some 100 gig waves. So alien waves are a good way to upgrade. So you don't have to add any capacity or cards to your core network. You can simply take 100 gig waves from your aggregation equipment and feed that into your photonic layer, directly into your optical mux or demux with no electronics whatsoever being added to your existing DWDM network. And we have done this maybe close to 20 networks around the world today. And even with networks which are loaded as much as 60 10 gig channels, we've been able to add 100 gig in all the remaining slots. So there's no BroadBand. And in the last 6 months or so, we've also added 200 gig channels. So alien waves at 100 gig and 200 gig can be done with really no equipment needed in the core network, in the existing WDM network. All you need to do is, use up a port in the mux demux. You probably have 80 ports sitting, but far less than 80 used. So this is seamless transition of seamless, I would say, scaling. There's no impact on existing services. You get a lot more capacity immediately. And it's just the CapEx, really, you just invest in the aggregation network and you add a DWDM CFP, and then you're done. Okay, so we are seeing large scale adoption of this technique for adding capacity in the core, simply because it's so much simpler and cost effective. In terms of new services, so in the packet network, we are seeing an immediate need to adopt 100 gig, where it used to be 10 gig before. So largely our networks and packet aggregation have been 10 gig on the line side and 1 gig uni, but we are seeing that move to 100 gig on the network side, on the NNI, a demand for 10 gig and 25 gig on the uni. So I think this is the phase of new access networks, packet transport access networks. And all customers, of course, will continue to want guarantees on their committed information rate and their excess information rate, so their peak capacities. Dynamic bandwidth resizing is a requirement. You have to be able to seamlessly change the bandwidth to the customer, because customers don't want to be paying all the time for bandwidth that they don't need. So they really expect some kind of bandwidth on demand. Guarantee of latency, jitter, and packet loss. So it's really zero packet loss, very low latency, 10, 20 milliseconds at best, and very low jitter. So you can carry on good video conferencing, because now video conferencing for several hours a day is the norm, and people want deterministic behavior out of this. And of course, O&M and performance tools are needed. This is what's happening to packet networks. In the core networks, it's OTN, of course, OTU4, which is 100 gig, but 100 gig is a 2019 or 18 story. It's now multiple 100 gigs, so 200, 400, even 600 gig. And the customer traffic is at least 10 gig, 25 gig, and often the customer handoff is 100 gig, not the network interface. So you need to support all these clients. Fiber channel is seeing increased adoption for storage. CPRI to connect radios is also something for which we are seeing a lot of demand. OTN has the flexibility to add bandwidth in 1.25 gigabit increments or 5 gigabit increments, and so that's UltraFlex, and also hitless upgrade of the UltraFlex. So you started off with some amount of bandwidth, you can now increase it. So, and if people are looking for very low latency and low power compared to packet transport, OTN scores. It has much lower latency, ultra low latency. Latency through a node is of the order of tens of microseconds, and then considerably lower power. Power is also an issue, at least used to be an issue. With oil prices at historic lows, maybe power is no longer very important, but cooling, is a pain anyway. So I was more or less giving you a generic picture right now. In the next 15 minutes or so that's left, I'll give you a view of how we at Tejas are approaching this problem in terms of what kind of solutions we are providing. I won't try to explain the boxes or the numbers and so on. I think that will be done one-on-one by our sales team if there is interest. But our approach in general has been to support multiple broadband access technologies to serve homes and businesses in the same product. So we support wireless access, GPON access, carrier Ethernet, and MPLS-TP access in the same product. MPLS-TP is also carrier Ethernet, but I use this term to mean Q&Q based or MPLS based. The other one is what I described so far as transformation, which is regular GPON is no longer good enough. You need protected GPON so that home users, which are homes, which are now becoming home offices, can get protection. Traffic engineering for business bandwidth, because they just really need the guarantees that so far they were okay, that most of the time they would be fine, especially if all the people were in the office. Maybe it was not so important, but now everybody being outside, it can be very, very unproductive to deal with poor quality telecom or internet connections. And very low latency is also important for, especially for mission critical applications. So I think these aspects which were there but not widely used are going to be demanded and much more widely deployed. The last one is the third aspect I talked about is scaling. So access networks are going to immediately scale from 10 gig to 100 gig. So the first ring that touches your cell tower or GPON, OLT, or any form of broadband for backhaul of broadband is going to become 100 gigabits. And it can happen on a packet platform. It can also happen on an OTN platform. And we offer both the platforms just so that you can stick with whatever you like best. And high capacity packet and OTN grooming solutions are needed. So we are offering a terabit of packet today, a terabit of OTN. But even that's not enough for the metro. So we'll have higher packet and OTN grooming solutions coming up. In terms of transmission speeds, seeing multi-terabit networks, 64 channels of 600 gig in the metro is something that we can support today. And it's something that customers are looking at. Just before this, I was on a customer call, and the customer was not even interested in 200 gig. He says, when can I do all wavelengths at 600 gig? Because they're really anticipating a lot more traffic. Here's a pictorial depiction of how we will evolve the products that we have built for the network. So we have GPON, OLTs, small, medium, large to serve the home market. We have 100 gig packet CPEs to serve the business market with MPLS or carrier Ethernet. So GPON and scalable to XGS-PON, carrier Ethernet, MPLS-TP, fixed wireless access. So we have pretty much all forms of broadband access. We also have 100 gig packet ring boxes in a one new form factor. We think that this is the new currency of the network interface. It's all going to be 100 gig rings, no longer 10 gig. We can protect the GPON. Again, all of the GPON can be protected with the class B today. And XGS-PON and regular GPON with 2.5 gig GPON are from the same card, just different ports. You can actually do it also from the same port in an upcoming product. In the edge of the network, it's going to be multiple 100 gigs with packet transport, or multiple 100 gigs with OTN. So we have high capacity packet transport and OTN aggregation solutions. We have 100 gig plus, 200 gig, 400, 600 gig. The smallest box we have in OTN is a 2RU, which has 2 blades, which works as a distributed 400 gig OTN. This is one of our most popular products, accounting for a sizable fraction of our revenue last year. Is just 400 gig of OTN with 200 gig interfaces and 10 gig feeding in. This is very widely used for packet transport in the metro, actually as a layer below routers to save on router bandwidth or router upgrades. The core of the network is WDM, so we support 100, 200, 400, and 600 gig waves based on OTN. We have OTN cross connects, which go from a terabit to multi-terabits. And so that's our offering to the network today, multi-terabit OTN. Alien wavelength is one of our most popular offerings. Many of our customers have used alien wavelength on their existing DWDM plant, on their existing photonic plant, which is often from one of the larger established providers, to add alien wavelengths from Tejas. They like this because they add one wavelength at a time without the need for any more equipment in WDM. You build your access and aggregation network and just feed a colored wavelength into your core network. It's literally as simple as that. I want to talk a little bit about the access network. So this is a series of slides where I show how our UltraFlex edge product. So it's a term, it's been on the slides, I've not used it so much, but we call our portfolio UltraFlex because it's very flexible in terms of being able to evolve, scale, or transform your network. Here I will illustrate the flexibility of a product which combines different forms of broadband access with optical transport. So let's say you wanted to do fixed wireless access to provide broadband quickly to many of your customers. Typically build an LTE-based access. Here we can put the LTE into our 1400 or it's a regular optical platform. Normally, an LTE provider does not do optical transport, so he would require you to hand off a GIGI to an optical transport platform. But given we are an optical transport player, so we built the LTE, or the broadband wireless access, or FWA, based on LTE, as simply an extension of our optical platform. So optical transport, 10 gig east, 10 gig west is built in. The same platform supports GPON and XGS-PON, and if you need more, you will need more capacity for that in the backhaul. So you can simply turn up another 10 gig ring in the backhaul. The very same platform with the third card will support business access on a 10 gig ring, and again, you can add more capacity in the backhaul. Tomorrow, you can upgrade by adding a 5G G-Node B card, and you still add more backbone capacity. We designed the backbone capacity, I have shown here multiples of 10 gig, but you could also start with 100 gig in the backbone. And everything that you see here comes of one 2RU box. All of the backhaul, LTE-based access, GPON-based access, and enterprise access with carrier Ethernet, everything is from a small 2RU product. It has 360 gig of capacity, and we have and all forms of, virtually all forms of access are supported. So I've come to the close of my seminar, so I want to summarize the messages. See, post-COVID, your networks will look very different. I think they already are. So we have virtualization across multiple industries. There's a huge spurt in work from home with virtually the whole population working from home. I've shown you stats on there's a sharp spike in broadband traffic, and there's a change in the distribution. You probably built your network to serve the business districts very well, but now all traffic is originating in the residential district where you probably just had some fiber broadband or GPON, so you need to scale all of that. But I see the good news. See, we are one of the only sectors for which COVID is great news. Okay, so who else will be cheering that COVID is going to lead to significant business growth other than telecom? The only thing I can think of is somebody doing a vaccine or a cure for COVID. Otherwise, transportation is down, airlines are down, Warren Buffett dumped all his airline stocks, car companies are down, oil is negative, so I don't know if you call that down or worse. Hotels, any kind of hospitality industry, restaurants, office space industry, everybody is in decline. Telecom sector is the only one that's growing. And I'm assuming this is not lost on your CEOs. I'm also assuming most of you attending this are engineering or planning folks. I'm sure your CEOs are, thinking, hey, this is a great opportunity for growth, and how do we take advantage of this? Because it's one of the few sectors for which COVID is positive. I mean, that is positive for business growth. So I think all telecom service providers have to take advantage of this shift. By the way, this is positive for telecom, not only for the web guys. Of course, Amazon Prime Video and Netflix is doing very well. Even Disney, I think, said their media portions are doing very well. Zoom is obviously doing very well. We're paying them a fortune for this webinar. But I think it is also good times for the telecom infra providers. I think finally people realize that telecom infra providers are very essential to keep the whole economy going. And I also see that this will be a time to change the business model. I think a lot of the times I used to see charts over the last few years where the favorite chart of everyone I met, well, it was not the favorite, it was the popular chart, they didn't like it, was that bandwidth is growing, but revenue is not. I think it's time to change that equation. You can start charging for gigabytes. And I think the industry is going to see this model. It's no longer everything you can consume, because that model means that the networks are getting choked. I think metering will come back. You will be given a certain amount of gigabytes. It may be large, 100, 200, 500 gigabytes, but it's not going to be unlimited. It's going to be metered. And finally, we're going to settle down to some price per gigabyte. Maybe it's as little as 10 cents, 20 cents, or whatever, but it's going to be a gigabyte price model, like phone calls were priced with minutes, or any other utility prices. So I think telecom infra providers, this could be the beginning of profitability, not only revenue growth, but also profitability. But in order to do that, what all TSPs have to do is add new broadband connections. Without new broadband connections, it's very difficult to take advantage of this this change in the way networking is being done. It's not only enough to add new broadband connections, we also have to deliver superior SLAs. People need to be able to work well from their home offices, as well as they used to work from their regular offices. So they need SLAs. Mission critical users will need hard guarantees. Capacity needs to scale across the board in the access, edge, and core. And this resizing of capacity cannot happen with any disruption. It has to be seamless. People need to get increase their bandwidth seamlessly, and so on. So, and then I'd like to say that we didn't think of COVID, but we were thinking of a flexible product offering for a lot of the needs that have just been precipitated by COVID. So I hope you will consider Tejas when you upgrade your network to address the needs that have come very, very urgently.